Hi everyone, welcome to my YouTube channel TechDataEngineer. So in this video we are going to learn retrieval augmented generation. Okay, that is basically called RAG. Okay, so we'll explain the RAG from basic to advanced and with the real world examples also, like what was the issue with normal LLM, why RAG comes into picture, what is the issue with RAG and all. Okay. So start with the video series. Okay. So basically first before understanding the RAG, we will understand what is the problem with normal LLM. Okay. So yeah. So as we know, LLM we have LLM like we have ChatGPT, Gemini, Cloud. Okay. Cloud we have. These are the LLM. Okay. So what was the problem with your LLM? So whenever you are writing something, you are asking, you are giving the prompt, and if it is specific with certain different context, okay? So in that case, because LLM don't know your company data, don't know your latest data, or it might be hallucinate, okay? So hallucination was one of the problem, and it is not specific to your data and don't know your latest data, so it might be wrong. LLM might be wrong, and that's why RAG comes into picture. Okay, so see if I'm asking something like why did my job failed? Okay, so it might be because of permission issue or schema issue. It will give like a general things. Okay, there might be some different issue also, error also. So if we are not giving certain context and if you are only asking this like why my job failed, so it will give the general problem like this is are the reasons and because of that it is failing. Okay, so it is general guessing, not the reliable. So this was the issue with our LLM. Okay, LLM means we have ChatGPT, we have Gemini, we have Copilot. Okay, so these are the things. Okay, and so for solving those problems, RAGs comes into picture. Okay, so as we know, RAG is the retrieval augmented generations. We have three things: retrieval, augmented, and generation. We will see all these three terms. Okay, when I'll explain the RAG architecture. Okay. So what exactly RAG is? So RAG is nothing but in one word, if you wanted to understand, it is a LLM plus your data. Okay, so whatever the LLM is there, LLM is getting trained with the huge million billions of data that is there. Okay, you don't have to do anything with that. So LLM is there, on top of that you are adding your data without retraining the model. So what happens sometimes in old things, what happens whenever you are doing something specific to your data, domain specific, you have to train your things. Okay, but in case of RAG you have LLM and your data, that's it, you don't have to do anything. Okay, so retrieval augmented generation, so retrieval means fetching relevant data, augmented means add it to the prompt, and generations LLM answer using the data. Okay, so now we will understand RAG first. Okay, so retrieval augmented generation is a method of improving language model output by adding relevant information. Okay, retrieve from the external source. So how we are retrieving from the external source, what are the relevant information we are adding, we will see it from the architecture diagram, but we can understand, right? RAG is a method for improving language model output by adding relevant information retrieved from the external source. Okay, so from external source it is retrieving and it is adding the relevant information, that is the simple basic definition of RAG. Okay, okay. So, so what are the things happen? So in that case of RAG process, so the system turns a user specific into a vector search of database for matching document and and insert those documents into a model prompt. Okay. So these are the things we have in case of RAG. Okay. So how RAG basically help? So this process help to model this process help to whatever the model we have to give more accurate response and reduce the error when the query depends on the current or specialized knowledge. So that is the thing. So LLM is something, and your data, because of your data, it is giving the current or specialized responses. Okay, so that is the benefit of using RAG. Okay. So, we will understand RAG is simple by using a real life example. Suppose you are writing an exam, and so RAG is basically they have given an open book. Take this book. We have you have questions. You can give the answer. And without RAG, whenever you are using, that was called closed book exam. But you don't have the book. Whatever the memorize you have, whatever the things you have already studied, from that only you have to give the answer. So that was the difference between without RAG and with RAG. Okay, so that is the real life example I have given. Okay, now the next part is the RAG architecture. Okay, so before RAG architecture, we will understand few things. Okay, so here is the user, like we are the user, we are writing the query, and we are writing the query, and we are asking the LLM to generate the code. So first we will understand what is things here. User here, query is our prompt. What is embedding model? So embedding model is not like it's like convert query and document into a dense vector that capture meaning. Okay. So embedding model, what it will do? It will convert the query and document into a dense vector. So what is vector? Vector is the numerical representation of a text, which I have already explained in my vector database things. What is vector database here? So vector database is the whatever the vector it is getting generated, it is storing in a database. That is called vector. So it is passing through a embedding model. So that is basically doing chunking, vectorization. Chunking means we have a book of size 1,000 page. So it will do the chunking like 500, 600 tokens. And then it will do the indexing also. So while searching the things from query, it will do the indexing so that it will fetch it fast. Okay. So I'll explain the retrieval also. So what is retrieval? So retrieve, what it will do, retriever find the most relevant passage or document to answer a query. Okay, so retrieval, what it will do whatever the relevant answer we have, it is used to find out efficiently. That's the retrieval used to do. Vector database, we have the vector things getting stored. Vectorize, it will do the vectorization. Embedding models convert this document and query into a dense vector. And then we have the orchestrations also. Orchestration, what it will do, this coordinate the workflow. Okay, and LLM, what it will do, LLM will give the answer. Okay, LLM we have that is the generate the what of the output we have. Okay, so that is the RAG architecture we have. So whenever user asks something, it will convert into a vector. Vector is storing in the vector database, and it will passing through an embedding model, and it will do the indexing. And then from that, when whatever the query we have asked, so based on this top of the RAG architecture, it is finding the relevant answer. It is giving to the LLM, and LLM generating the prompt. So that is the simple architecture we have. Okay. So what is the query encoding here? So query encoding is basically that process start with the user query, okay? And whenever user is getting writing the query, the system convert that query into a numerical representation that is called a vector using an embedding model. So from embedding by help of embedding model, it is converting to a vector. So so instead of matching only the exact words, the vector captures meaning. Okay, so I have already explained it is capturing the from text to numerical. So this makes it possible to compare the query with the stored information, even if it is wording different. So because wording different means it is based on the vector. Okay, so how vector is how text is converted into different vector. So I have already explained my past video. So if you want, you can go through that. Okay, then it will do the data indexing. So for this comparison to work, what happened basically, the document themselves must be prepared so that like ahead of the time the system breaks document into smaller chunks and convert into the vector using the embedded modeling. Okay. So these are the things happen. So this vector along with the original text stored in the database. Here it is stored in this database, vector database. Is built to search by the meaning. Okay, not through the keyword word. So how it is doing the semantic search. Okay, so these are the things we have. So we understand these things, how indexing is work, how what is embedding model, what is the chunks, what is the vector database, what is vectorization, how it will happen, and how retrieval works, and face the retrieval like relevant things based on that document we have provided, and it will give the output to the user. So that is the RAG architecture. So if we'll see a step by step, first step is the data collection. So you whatever your knowledge we have, so we have the PDF files, database, logs, Confluence document, or Kafka. So these are the anything which can be your knowledge in case of your training. So example, we have the BigQuery IAM error. So I am asking some error related to IAM, BigQuery, or data snapshot failure, or Airflow DAG failure. So we have the documentation for each of the failure, right? So in that case, what will happen? We are giving as a RAG. Okay, external information. Then chunking, what will do LLM so LLM basically cannot like process the huge data. So what it will do, it will breaks into a smaller chunks. Okay, so it will breaks into the smaller chunks. Okay, so like 100 suppose 100-page PDF we are converting into 500, 600 character chunks. So that way we will do the chunking. Okay. The next step is the create embedding. So embedding creation means like converting text into the number. So if suppose we have the text like BigQuery access denied error. So how we are converting into the vector. So these are the vectorization. We are passing through the vector model. Okay. So that is the create embedding. Then we have the why we are converting to the embedding, which as we already know, like computer understands number more than these things. Okay, so computer understand numbers, not the meaning. So that's why similar text we have the similar vector. Okay, and then we are storing embedding into the vector database. So we have the database. What we are storing the vector plus original text. So we have options like Pinecon, we have it, and then BigQuery vector search. These are the database we have. We are storing these things. Okay. Then Google search for meaning, like whatever the things we have, whatever the answer query we are writing, it is asking and it is giving the relevant information. So okay. And then we have user ask questions like why snapshot table creation failed. So this question converted into embedding, then this will go through the embedding model, getting stored in the database. It is finding based on the indexing, and it is giving the relevant answer to LLM, and LLM generate the response. So these are the process happen. So it will basically, so vector DB finds the top 3 to 4 similar search based on the semantic search, that's called retrieval. Okay, so we are using the semantic algorithm to find the top to 3 to 4 things. Okay, so it is every time it is not the case where every time we are getting the exact relevant answer. So it is finding the 3 to 5 most similar chunks like IAM permission error, snapshot create triple denied, dataset access issue, and based on this all three we are getting the answers, best relevant answer. Okay, based on the semantic search. Okay, so here I have already explained here what is the semantic or retrieval. Okay, so based on semantic algorithm it is retrieving. Okay, and then we have the augmented prompt. Okay, then LLM generate the final answer. So that is the things we have. Okay, so that is the things we are, that is the basic workflow of the our rack. Okay, how we it is getting generated when a user give the prompt. Okay, so then we have like why RAG is better than model training. Because in case of fine tuning is expensive. If you are doing fine tuning with our data, that is very expensive. Retraining is slow, so that will take time. So in case of RAG, it is fast, cheap, and accurate also. Okay, so you have the data model. What is the model you are using? That is already you have. On top of that, you are giving your domain specific data. So that will help to understand your problem and give it the correct result. Okay, so that's why RAG is very important nowadays. Okay, thank you. Thanks for watching.